Hello everyone. In this particular lecture, we'll continue the discussion on the clipping circuits. So before going to see the operation of this mentioned clipping circuit, we have clipping circuits are of two types. One is shunt clipper and second one is series clipper. So what is shunt clipper is nothing but what are the nonlinear element which is responsible for the clipping operation that should be in parallel with output. And in case of series clipper, the nonlinear element should be in series with the output. That is the difference between shunt clipper and series clipper. So whatever the clipping circuit we have taken here, this is the shunt clipper, because across nonlinear element diode we are taking the output. So it is example for the shunt clipper. And if you observe this circuit, we have AC source 10 volts peak to peak value. This is peak to peak. That means we have provided here phi sine of 2 pi ft signal with the frequency 1k. That means time period is equal to 1 by 1k, that is 1 millisecond. So we have given here 10 volts peak to peak sinusoidal signal with peak value phi, and the time period is equal to 1 millisecond. This type of signal we have given as the input for the circuit. And here resistor 1 kilo ohm is available, and diode D is available, and reference voltage 2 volts. The operation of the circuit will be similar whether you are taking the reference voltage 2 volts or minus 2 volts, or you are taking 0 volts. Okay, it will perform in the same way with the slight difference because of the change in the reference voltage. That is what we are going to see. So you can work with this one 2 volts, minus 2 volts and 0 volts. Okay, so what will happen here, by providing the 10 volts peak to peak sinusoidal signal, what portion of the signal will be clipped, what portion of the signal will be transferred to the output, we are going to see in its operation. Okay, so and once again I am drawing the circuit here. So here P side is upside, N side is downside for the diode, and here we have provided ground. You can take here VR is equal to 0. Okay, it is a case where reference voltage VR is equal to 0, then what will happen? We are going to see. Because it is a first circuit, I will take some time to explain this one very carefully. Then if you understand that particular operation clearly, then you can able to proceed to understand the remaining circuits very easily. Okay, so see here, input signal is a sinusoidal signal, that is what we have taken. And in all the examples I will take peak to peak voltage is minus 5 volts. Wherever it is required to change this particular peak to peak voltage, I will tell at that particular time. Now for this circuit is enough. Okay, and I will assume ideal diodes, and I will give the note point with the practical diodes. Okay, ideal diodes we are taking. So ideal diode, you assume ideal diode, this one, whenever it is in forward bias, then it can be replaced by short circuit. In short circuit, voltage is 0 and current is not equal to 0. When we can say this particular diode is the forward bias, means it is a P side voltage and here N side voltage is there. So whenever Vp is greater than Vm, we can tell diode is under forward bias. Since it is ideal, we can replace the diode with short circuit. Across the short circuit, voltage is 0, and through the short circuit, current is flowing. That means not equal to 0. So this is the analysis we have to remember when the diode is under forward bias. Now if you take the diode is under reverse bias, what will happen? For example, diode is under reverse bias, that means Vp is less than Vm, then the diode is said to be in reverse bias. And in reverse bias, the diode, ideal diode, is replaced by open circuit. Open circuit means in open circuit current cannot able to flow, so current is equal to 0, but across the open circuit you will be having certain amount of voltage. So V is not equal to 0. These are the basics, are very much important to understand any clipping circuit. Okay, now we will see the operation of this particular clipper. So basically, since here we have taken here actually VR is available and VR is equal to 0 volts we have taken. So voltage source value is 0 means a short circuit. Okay. So what we can able to take here, inside voltage is 0 here. In this particular case, inside voltage is 0. So if you want the forward bias of the diode, okay, in all the clipping circuits, you can able to think in this way. For what voltages of the input signal, diode will get forward bias. For what voltages of the input signal, diode will get reverse bias. In this manner, you need to think. Okay, since here inside is directly grounded, there is no DC battery. Okay, VR is equal to 0 volts. So inside is directly grounded. That means VN is equal to 0 volts. VN is equal to 0 volts. But what about VP? Because in order to know about the forward bias or the reverse bias of the diode, you need to compare VP and VN, P side voltage and N side voltage of the diode. Since already we know that VN is equal to 0, now you need to know about the VP. Okay, so VP is directly equated to VI because whatever the supply voltage is there, that is available on the P side of the diode only through this particular resistor. Okay, so initially there is no current or very little amount of current is there. So you can able to treat the voltage drop across this particular resistor R is negligible. So that whatever the voltage you are applying, that entire voltage will be available on the P side of the diode. So I can take VP is equal to VI. Understanding of this one is important. Since inside of the diode is grounded, we have taken Vn is equal to 0 and Vp is equal to Vi. Okay, Vp because supply voltage is available at the P side of the diode only. So that Vp is equal to Vi. But Vi is variable. Okay, Vi is changing actually from minus 5 volts to plus 5 volts. That means in this one, you have minus 5, minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, 5. Like this every time, for every cycle, the voltage of the input is changing from minus 5 to plus 5, including the non-integers also. That means minus 4.5, every value. Okay, from minus 5 to 5, this is a swing. Okay, one full swing of the input is nothing but that is from minus 5 to plus 5 volts, including the non-integers in between all these integer values. Okay, from minus 5 to plus 5, the input is the variable, but Vn is 0. Okay, so what is the forward bias condition? You assume that diode is going to the forward bias. To happen this one, Vp should be greater than Vn. But what is Vp? Vp is nothing but Vi, but what is Vn? 0. That means for all the values of the input which is greater than 0, that means indirectly Vi is positive. For the positive half cycle of the input signal you are talking. Okay, so we are satisfying this Vp is greater than Vn, that means diode is going to the forward bias, so the diode can be replaced by short circuit. Okay, so diode will be available in the circuit, but that is acting as a short circuit. So you replace the diode with the short circuit in the original diagram. That means here diode place is this one. We are replacing that one with short circuit and you are taking output across the short circuit only. This is the input, but your input is greater than 0 in this particular case. Across the short circuit you are taking the output. Already I have mentioned that across the short circuit output voltage, that means voltage is equal to 0. So in this case output voltage is equal to 0. So we have taken Vi is greater than 0. Now another case is simply Vi is less than 0. That means you are looking for the reverse bias condition. Reverse bias means the condition is Vp is less than Vn. So Vp is nothing but Vi, Vn is nothing but 0. So whenever Vi is less than 0, so directly you can take this condition from this one. First condition is Vi is greater than 0. Second condition is Vi is less than 0. Okay, so in this particular condition, what is the input range? Input is negative half cycle now. So when the negative half cycle you have taken, then diode is under reverse bias, and in reverse bias the ideal diode can be replaced by open circuit. Then the equivalent circuit will be like this. Diode is there, but that is acting as open circuit. You need to take output across the open circuit. So across the open circuit, previously I have mentioned that there is a voltage. Okay, how much voltage will be there now? What is the output voltage means? See carefully here. Since it is open circuit, in open circuit infinity amount of resistance is there. That is in parallel with the resistor R. Sorry, that is in series with resistor R. So something is added to infinity means again you will get infinity. That means there is no current through this particular loop. So current is equal to 0. Current, so many times we are going to get this particular case. So listen carefully since you are seeing this one first time. So I is equal to 0. Since current is 0 through the resistor, According to Ohm's law, V is equal to 0 because V is equal to I into R. R is there but I is 0. So that voltage across the resistor is equal to 0. So if you apply KVL here, supply voltage is equal to voltage drop across the resistor and output voltage. But here voltage drop across the resistor is equal to 0. So whatever the supply voltage is there, entire supply voltage will be coming as the output. Like this we have to take. So in first case where Vi is greater than 0, we got output is equal to 0. That means for the positive half cycle, we did not get anything. Okay, the output is 0. For the negative half cycle, we got output is equal to input. That means the negative half portion of the input signal has been transferred to the output. But whenever you are applying the positive portion of the input signal, output is becoming 0. Okay, so whatever in red color I have taken here, I have rounded, that is nothing but transfer characteristic equation. The transfer characteristic equation is the equation which is relating the input variable Vi and output variable V0. That means simply you can write when Vi is greater than 0, V0 is equal to 0. And whenever Vi is less than 0, V0 is equal to Vi. So this is nothing but transfer characteristic equation. And if you draw this one, whatever you are going to get, that is called transfer characteristic curve. Okay, transfer characteristic curve. Here I am going to draw. Generally input wave and output wave are available with respect to time. But if you take like this, on x-axis Vi and on y-axis V0, then you are going to get the transfer characteristic curve. So how to draw that one? You see this equation, then according to this equation, you can able to draw the transfer characteristic curve. So when Vi is greater than 0, that means positive value, output is equal to 0. So on positive x-axis, Vi is positive, so output is equal to 0. For negative values of Vi, output is equal to input. That means Y is equal to X. That means straight line passing through the horizon. So like this you can able to draw. This is indicating output is equal to input. This is indicating output is equal to 0. Okay, now I will draw the output signal also. So V0, this is V0. So for the positive half cycle, we got output is 0. For negative half cycle, we got output exactly equal to input. So there is no positive portion. Wherever input is there, that is coming like this. Okay. So in this way, we can able to get the output signal also. Input signal and output signal. So we have completed one circuit operation like this. Okay, here we can able to consider the reference voltage is 0. So what is happening here? What is the conclusion we can able to take? The voltages which are above that reference voltage 0 volts has been clipped. The voltages which are below the reference voltage 0 volts have been transmitted to the output. That is what we have to understand. Okay.